So, which statement correctly describes the end behavior of the function? To figure this out, we have to know what the degree of the function is. How do we figure out the degree of this function? What do we look at? Not the square root. The exponents. What do we have to do with the exponents? Add them up, okay? So any factor that isn't raised to an exponent, what can you assume that exponent is? 1. So that last factor is raised to a 1. And don't forget the little x in the front. So what is the degree of this function? The degree is 4. So now that we know the degree, is this odd or even? This is an even function. What is its shape? A parabola. But notice the negative in the front. When it has a negative in the front, what does that mean for the function? It flips over the x-axis. So it's going to be an upside down parabola. So why that is important is that helps us determine the end behavior. Okay? So the left side of the graph, is that negative or positive infinity? Towards negative infinity. That means the other side is towards what? Positive infinity. All the way up is towards positive or negative? Positive infinity. And then all the way down is negative infinity. So as my graph is getting more negative, what are my y values doing? Going towards negative infinity. So let's cross off the ones that aren't doing that. As my x values are getting more positive, what are my y values doing? Towards? So what's my answer? B as in boy. Okay? Does that make sense, y'all? So we have to figure out the degree. And if it's got a negative in front, then it flips the graph. Okay? All right. We're going to skip the extra credit question. If we have time at the end, we'll go over it. Let's look at number 3. So the graph is shown. What's the equation? How do we figure this out? How did y'all do it? How'd you try to do it? So some of y'all graphed each one of these, right? And then you seen which one matched? Okay, that's not wrong, but it might be extra work, okay? It increases your chances of entering one of these wrong. The easier way I think you could do this is identify what the x-intercepts are. So you want to find the x-intercepts. So how many x-intercepts do I have? 3. What are they? -3, -1, and 2. How are my x-intercepts going to help me find my factors? Because think about it. We could look at a factor and tell what the x-intercept is. What do? Change the sign, right? So I could do the reverse to find the factor. So what's a factor for this x-intercept? +3. So I write x plus 3. What's a factor for -1? X plus 1. And then what's a factor for 2? That's right, x minus 2. So what we could do, smart test taking strategies, okay?
Yes.
Is cross off the ones that don't have these factors, okay? Does A have x plus 3, x plus 1, and x plus 2? Okay, so don't cross that one off yet.
It's
-2, sorry, y'all. Thank you for correcting me. What would I do without you? Okay, x minus 2. All right, so is A it? No, let's cross that one off. Let's get B. Okay, look at C. Is C it? Nope, C's not it either. How about D? It must be B, right? Okay, and also notice how B has a negative in front of it. And look at the shape of your graph. Are my S-shaped graphs normally that shape? No. So that means it's flipped. So that's what gave it away that it has a negative in front. All right? Does that make sense? Okay. But if you need to use your graphing calculator, figure this out, you're not wrong. Okay? Do what works for you, whatever's easiest. Let's look at 4. Which statement describes the transformations used to obtain the function? All right, again, with this, guys, we have to look at our transformation chart. I'm going to give you guys one. You'll have your own individual transformation chart, so you won't have to worry about looking up here. But what we have to figure out is we have a transformation here at negative 11. What letter's in the place of negative 11 up here? H. What is our value for H? Positive 11, okay? Because we have to change the sign, okay? When H is positive 11, what kind of transformation do we have? Horizontal translation right. So let's cross off the ones that aren't going towards the right. So A does not work for us, and neither does D. Now we have to look at the negative 20. What letter is in the place of negative 20? K is. What's our value for K? Negative 20. So when K is negative 20, what kind of transformation do we have? Down. So what's our answer? C. Does that make sense, guys? Okay. Let's look at number 5. This one stumped a lot of us. But y'all gonna be mad when you figure out the easy way to do this, okay? Because we did talk about this in our notes, okay? But if you're not reading your notes, you don't know. How many turning points does a function have? What did everyone in here do? You had to graph it. And that's not wrong, okay? You can graph this, but then you have to adjust your window. You have to adjust it a lot. So if you can't see the tops and bottoms, you have to adjust the Y min and Y max out to what, 30,000? To actually see the tops? How many turning points did we see? Want to hear an easy way to figure this out without graphing it? Okay, there's a trick. There's a trick to this, okay? First, we figure out the degree of it. What's the degree of this function? 5. Again, we're looking at the exponents. The ones that don't have exponents are raised to the first power, and we add them up. Did you know the number of turning points? Oops, sorry. Is actually 1 less than the degree of your polynomial. That's in our notes. Okay? So, from that information, as long as you figure out the degree, you know how many turning points we have. Okay? Does that make sense? So that lines up with this, doesn't it? What you're doing here and graphing it, it's not wrong. It's another way to figure it out. So if you brain fart tomorrow and don't remember, by all means do this. But understand you're going to have to adjust the window. Okay? Any questions? Let's flip the page. All right, number 6. So we want to place an x in the table. And this is a transformation equation problem, isn't it? So the very first question, true or false, we have to figure out if the function is a vertical stretch of the parent function. So what letter is in the place of vertical stretch? A is. What is this function's value for A? A is 4 for this function. When A is 4, what kind of transformation does it give us? So is this true or a false statement? True. Okay. Okay. So the function g of x is symmetric with respect to the y-axis. A lot of us didn't know what that meant. That means, here's the y-axis, the up and down arrow. It looks the same on the left and the right. Is that true for this function? No. And here's why, okay? This transformation right here, when you subtract 5, what letter's in the place of that 5? H. What kind of transformation happens when you have h of 5?
Right.
You're moving right. So my function is going to be somewhere over here, isn't it? Is that symmetry on the left and the right of the y-axis? No. So this is false. Finally, how do I know if this function has an absolute maximum? Well, I could graph it, right? What's an absolute maximum? That means the very lowest point, okay? So does it have one? Does it? Yes or no? No. Well, when you graphed this, did it have an absolute maximum? Who graphed it? You're not wrong. Did y'all do this problem? How did you figure it out? Another way to figure this out is, what is the degree of our polynomial? What is the degree of it? Say again?
8.
It's 8, right? So the degree is 8. Is this even or odd? Even. What is this shaped like? A parabola. Can a parabola have an absolute minimum? Yes.
Yeah.
Can it have an absolute maximum?
No.
No. Because you have arrows that keep pointing in the positive direction. There's not going to be an absolute max. Okay? So this is a false statement. So know the shape of your graph based on the degree of your function. Okay? If there's an arrow pointing in the direction of where the absolute highest point is, there's not going to be one. Same thing if there's an arrow pointing in the absolute lowest. There's not going to be an absolute lowest. You might have local maxes and mins, but not an absolute. Any questions? Let's look at number 7. So we're going to place an x in the table to show whether the graph crosses or is tangent to the x-axis at the x-intercepts. Does anyone remember how we figure this out? Am I going to have to graph all of these? If you did, you're not wrong, but it takes forever. Yes? Because you got to figure out the windows. The easiest way is to look at each factor. If the factor is raised to an even exponent, what does that mean? Are we tangent or does it cross at an even exponent? It's tangent. That means it touches. Okay? If the factor is raised to an odd exponent, you better be writing this down. Okay? What does it mean if it's raised to an odd exponent? It crosses, okay? Those are your two options, one or the other, right? So we're not adding all the exponents up this time. We only do that to find the degree. For this one, I don't care what the degree is. I just want to know if each individual x-intercept is going to be tangent or does it cross. So look at the first one. Both of those are even exponents. So what do we have? Tangent or cross? Come on, guys. Tangent. Next line. What kind of exponents do I have there? Even or odd? Odd. Crosses. Good. Next one. Even or odd? Tangent or crosses? It's easy when you remember that fact, okay? And then finally, when we have odd exponents for the last one, tangent or crosses? Crosses.
What? That's a word under raise.
Raised odd exponent. Factor raised to odd exponent. Does that make sense?
Yeah, I thought it was too.
Nope. Odd exponents cross through.
Looks like 4x.
The exponent is 1.
Yeah.
The exponent is
We
1.
don't add, hey guys, when we figure out if it's tangent or it crosses, you're not going to add the exponents. You're just looking at each individual x-intercept, each individual factor. Does that make sense? Okay, any questions? And that's legitimate. Everyone in every single Algebra 2 class has had that same concern, okay? Let's look at number 8. Number 8, consider the function. What statement is correct about the maxima and minima of the graph? Okay. First off, what's the degree of this function? 5, right? So it's degree 5. Is this even or odd? Odd. Okay. So what's the general shape of the graph going to be? Backwards S. If you don't know that by now, we've said it over 50 times. You need to memorize this. Okay? So when I have arrows pointing towards my maximum and towards my minimum, am I going to have an absolute highest or absolute lowest point in my graph? No. So that means no absolutes. Cross off the ones with absolutes. When could I have an absolute max or min? When my graph is even, okay? So if I have a parabola, I could have an absolute minimum. If I have a downward shape parabola, I could have an absolute max. Does that make sense? Everything else in between, I could have a bunch of locals, unlimited amount of locals, okay? So now I have to figure out how many of each of these locals do I have. That's when I have to graph this, okay? That means you do have to graph this one and figure out, okay? Now, you can do one of two things. You could graph this or use that interval test. Remember the interval test where you find the intervals? Just graph it and adjust your window, okay? So graph this, adjust the window so you can see the turning points. And now that I just think of it, this is going to help me answer it without graphing it. I didn't even realize it. What did we say about the degree and the amount of turning points?
1 less.
1 less. So if I have 4 turning points, how many local maxes and mins am I going to have?
4.
2 of each, right? So which one's our answer?
B.
B.
Dang, bro.
Now, if you forget that, that's okay. You could zoom, make sure you adjust your window to see the turning points. Okay? Both of those are correct ways. Do we want to see how to do the extra credit? Stop putting your crap away.
No.
Yes.
If you don't, be respectful of me while I'm still up here talking. Okay? Let's look at the extra credit. Because honestly, this may give you a pass or fail depending on if you do it. Okay, so this thing is talking about volume. We need to know the formula for volume. What is the formula? How do we figure out volume? Remember from geometry?
Nope.
Okay, that's area. Say it out loud, Sydney, please. Length times width times height. Okay? So they give us dimensions for 2 of the boxes. The first box has the dimensions x times 3x times x plus 4. But then they say the second box has dimensions that are 2 inches longer than the first box. What does that mean? What do I got to do? Add 2 to what? To each dimension. So I'm going to add 2 to the first one, x plus 2. Add 2 to the second one, 3x plus 2. And then to the third one, x plus 4 plus 2, which when we simplify that becomes what?
X plus 6.
X plus 6. So which one of those volumes is the correct one?
C.
C. Now, this very last part, if the volume of the second box is 555 cubic inches, what is the value of x in inches? To solve this, think about it. How do we solve for x when we graph it? How do we find solutions for x? Y equals, and you're going to type in your volume, okay, for the first line. This is extra credit, okay? So if you don't know how to do this, don't worry about it, all right? For the second line, you're going to put what the volume actually is. So if you want to figure out what x is, what do you think is going to be? Where the lines intersect, okay? Lines intersect. And then you do the calc function and intersect to find that. And that's going to be your answer. So if you want to figure that out on your own time later, the actual answer was approximately 3.2 inches. Okay? You could try that later. If you don't have a graphing calculator outside of this class, there is one on Google Classroom that's just like these, okay? Does anyone have any questions?
No.
Good? Okay.